Arithmetic is that there's a common ratio where you're constantly multiplying by a new or by the same value every time. And so like what I've got listed here, a sub 2 is the same thing as the previous term, a sub 1 times r. A sub 3, previous term, a sub 2 times r. But we already know a sub 2 is a sub 1 times r, so you got a couple of r's. Now, how about, like I was saying here, if we did one more iteration, a sub 4, we could say, all right, well, that's the same thing as a sub 3 times r. And a sub 3, we said, was a sub 2 times r. And a sub 2 was a sub 1 times r. So do you see the correlation between how many r's there are and the term that you're looking for? What is it? It's one less. So if I'm looking for the fifth term, I need how many r's? 4. If I'm looking for the sixth term, I need 5. If I'm looking for the nth term, I need n minus 1 r's. And so there's our explicit formula for geometric sequence. That's our third formula, by the way, those of you that are keeping track, right? We've had 2 such formulas so far. We had arithmetic sequence. Freddie, you definitely don't want to miss this one, right? Get this one down. I'd put some little stars around it in my notes if I were y'all. And so we've had arithmetic sequence, we've had arithmetic series. Here, this is a geometric sequence. And this is going to help you with some of the homework questions that I posted yesterday. Okay. Now, I don't want to brush over the fact that I've got something highlighted at the top. What's highlighted at the top is how you find your R value. How you find the common ratio is by dividing, okay? So maybe you divide the second term over the first term, or third term over the second term, or fourth term over the third term. All right, that's how you find your common ratio each time. Louder? Sure. That's how you find R. Yep. And it looks more complicated than it is. That's just like saying, take the current term and divide by the previous term. That's how you find your common ratio. Mitchell, you good?
Yeah.
All right. So I think we're ready to maybe start an example. All right, let's take a look at our example. So we're given this sequence. The numbers are in orange up there. There's 3, 6, 12, 24. Now, Alfredo, tell us why we know this one's not arithmetic. Why would this one not be considered arithmetic?
Because it doesn't have a...
Very good. Because it doesn't have a common difference, right? If it was arithmetic, we'd be going 3, 6, 9, 12, 15, 18, so on and so forth, right? So it's, to go back to Mario's point, this one is non-linear. The slope, if you will, is not constant throughout. Okay? So we want to consider, gee, I wonder if this is geometric, right? Jack, how could you determine if it's geometric? Yeah. Like from the last slide, how do we calculate common ratio? Go ahead and help me find my R value.
R minus.
Well, from the last slide, it was highlighted in yellow. What we were talking about was just divide 6 over 3. Yep. And divide 12 over 6. That's 2. And divide 24 over 12. That's 2. Everybody feel comfortable now saying that this one is definitely geometric? Right? So your common ratio, thank you, Jack, we've calculated to be 2. So let's write up our formula. Okay, here we go. A sub n equals a sub 1 times r to the n minus 1. So let's sub those two, Denegri, let's sub those two parameters. What's a sub 1? Andrew?
3.
First term, and then what's your ratio? Good. All right. 3 to the power of n minus 1. Now what I can do is I can find my 37th term. Now, this is where the calculator comes in handy because I don't know what 2 to the 36th power is. But 3 times 2 to the 36th. What would the 100th term be? 3 times 2 to the 99th. Thank you. I'm just writing and not thinking. Okay. And again, these numbers are so large that I need a calculator to plug them in and see what we would get. Okay.
I know what we're doing.
Yep.
So we put the scientific notation.
Correct. I would use either scientific notation or I would leave it as this form right here. Oh, yeah. I'm sorry, Stephen. Maybe a couple decimal places would be perfect. All right. Here's our next example. This one looks a little weird. Bill, what do you reckon? Is this arithmetic or geometric?
This is arithmetic.
All right. So what would your common difference be? How do you go from 5 to -5? All right. So we would subtract 10, but then to get from -5 to +5, we'd have to add 10. So I'm not thinking it's arithmetic, right? Because it's kind of bouncing back and forth. Okay. And then Finley, you said you think it's geometric?
Yeah.
All right. What would be your common ratio? -1. All right. Let's test that theory out. 5 times -1, -5 times -1, 5 times -1. So we see we're bouncing back and forth. Okay. So my formula, 5 times -1 to the n minus 1. All right. So Nash, I don't need a calculator for this. I just need you. -1 to the 55th power. What do you think that term's actually going to equal? Very good. I concur. All right. Evan, how'd you do? Good. All right, buddy. I appreciate you.
We should take that quiz. No, I think they're.
Sure. What would you do to everything on the first equation?
We'll put it in 10.
Multiply by 10.
X is 3.
X plus 2 equals 5. So X equals 3. Is that what you should have put?
And That one's
-10,
back is to -10, +3.
Right.
Plus 3x plus 10. Yeah. What did you put? Did you get it right?
I don't know. We're about to see. -310. X equals 3. Yay. Good job, Evan.
Bam.
Bam.
All right.
What's that out?
What's that outline?
5 out of 5.
No.
No, he doesn't get an OBQ on a makeup. All right. Okay. So good. Nash, how'd you know that so easily? Yeah. -1 raised to an odd power. Here we got 5 times -1 to the 102nd. So we know that's going to be +5. All right. Now that's pretty boring. That's pretty trivial. They just bounce back and forth. But it's a good illustration of how this might not necessarily fit with Mario's notion of like exponential growth or exponential decay. Sometimes a geometric sequence maybe breaks that rule of exponential functions. Remember, with exponential functions, the base has to be between 0 and 1 or greater than 1. Obviously, this is an example contrary to that. All right, and then now we can see we got a little word problem. Okay. Rebecca inherited some land. It's going to increase 5% per year, or at least it has for the last 5 years. And it says if this appreciation rate continues, how much will the land be worth in 10 years? Now think about the context of where we're at right here. Okay. we're thinking about geometric sequences. What would my A1 be? What would my first term be? 50,000. What would my base be? What is the appreciation rate?
0.05.
All right. So I can say that the value of the land is going to equal 50,000 times, what's your rate? 0.05 to the, let's be consistent with our notation. We'll say A sub n minus 1. All right. So worth in 10 years, I'm going to be doing 0.05 to the 9th. I gotta be honest with you boys. I feel like this smells kind of fishy. I think it's supposed to be 1.05. So what we can do is we can be logical thinkers, not stinkers. We can run the numbers as is, and then we can think, well, wait a sec. It's appreciating, so it should be more than because if I run this number right now, 50,000. Suppose I didn't smell anything fishy, and I was just like, oh, humpty dum, times 0.05 to the power of 9. Right? All of a sudden, that's a T90 number. Okay, and I've messed it up. So I'm gonna hit. Yeah, that's good, Eli. Second insert. Now we've got a much more appropriate number. Okay. So with these word problems, I mean, all the time I get guys that will turn in an answer that's like very illogical. It doesn't make any sense. Think logically about it. If it's appreciating at 5% per year, then 77,566 seems like that would be appropriate in 10 years. Mario. Once per year. Once per year. Who is singing in here?
Finley, of course.
Why are you singing, Finley? Do what? Trying not to move?
Right.
Oh, to brighten up the mood. Okay. I love a good song. What were you singing?
You hear by Jello
Oh.
Beaker. I might swerve in that corner. Whoa, whoa.
Y'all might as well be talking. What are you doing?
I was about to throw this pen.
Y'all might as well be talking a foreign daggum language. I don't even know who Tweaker is. The song is called Tweaker, and his name is
He just swerved.
LaMelo. Like,
LaMelo, brothers. LaMelo and
Oi.
The one that didn't make it to the league. The one that's not good enough at basketball. He's good at rapping.
77,566. Was there any change involved on this? 41. All right. Here we go. We're going to go through as many examples as we can to get you guys prepped and ready for the Delta math. So let me get Christian to help me figure out, is this arithmetic or geometric, and how do I know? What do you think, my friend? All right, that's a good guess because this is in the section of, geometric sequences. What would your common ratio be then?
Yes.
Well, can we is it okay to get some help?
Yeah.
All right, so can we ask Aiden, how do I go about, do you remember what we had highlighted in yellow? How do I find my common ratio? Yeah, very good. So we're going to do 54 over 81. And what y'all said that is? 2/3. 36 over 54. And 24 over 36, right? So the way that we're figuring out, find R first. Okay. And in this case, we did, and y'all said it's 2/3. So now A sub 12 is going to be 81 times 2/3 to the 11th power. And then I just whip out the old calculator. And by the way, it does say find the nth term rule. So we'll just go ahead and write a sub n equals 81 times 2/3 to the n minus 1. So technically that's what they asked for initially there. 81 times, whoops, 2/3 to the power of. Ooh, I wonder if I should put the 2/3 in parentheses.
Yes, I did. I did.
Makes me nervous. I think I will. Just to be on the safe side. 2/3 to the 11th. Now, oof. Okay, so this is the hard part. Can I hit math, enter? Yes. 2048 over 2187. Uh-huh.
Yeah.
Did I say 2187? By the way, that's a little calculator trick that should be well known at this point, right? Math, enter. 2187. Yeah. All right, because I don't think I would be satisfied with the decimal approximation on this one. Okay, so just FYI, Jack and Mitchell, the DJ, are y'all working with me?
I did math enter on mine.
Yeah,
It just
give
stayed
that
with
a
that.
All right, good question. Did you enter 2/3 like I did, or did you do 2 divided by 3?
I did 2/3.
All right, let's do 81 times parentheses 3 fractions 2/3 raised to the power of 2 by 3. Oh, look at that.
Boom.
Doesn't that drive you crazy?
Effective.
I'll tell you what happened to me the other day. I was making some tacos. And what do you got to have when you're making tacos?
Cheese.
You got to grate some cheese up. All right. And so I couldn't find my cheese grater. And I looked through, we have a big old wide drawer where we keep all of sundry kind of like tools and such. And so I was like, Mrs. Morgan, I can't find the cheese grater. Where is the cheese grater? And she's like, it's in the drawer. And I'm like, I've already looked in the drawer. It ain't in the drawer. What's the matter with you? And she walked right over there and put her finger right on it. And it made me so mad. Made me so mad. All right, so good. There we go. Example 4. Here we go. Farmer buys new tractor, depreciates by 6%. So what do you think your base should be?
0.06.
500.
Oh, 0.954.
Yeah.
How about 0.94? That's what I suspect. Now, truth be told, I've got, Freddie, you with us? I've got a little experience in dealing with problems like this. So like with appreciation and depreciation, I know that you're starting at where? You're starting at 100%. And then you're either dropping off or you're adding 2. So that's why that base would be there. 15 years, what would we say? All right, so A sub 15, and we can just run the numbers. 31,000. Oof. Makes me sad when property depreciates.
What type of tractor was that, I wonder?
International Harvester, I bet.
John Deere. Those don't depreciate like that.
Hey, what did the female farm implement say to the tractor? Pull me closer, John Deere. 31,539. Is that what we got? All right, we'll handle, I don't want to do those today. Finite geometric series, we'll handle those at another time. Let's go to the delta math. Get this out of here.
Before you just not get to either.
No, I was sick of it. I trimmed it because I was tired of it. Those of you at home wondering what he's talking about, I shaved my beard on Friday.
10 years ago.
Seabass. Yes.
Like All
All right, so this assignment is called classwork 9.2. Okay, classwork 9.2. It's got a bunch of a mixed match between arithmetic and geometric. So like those questions that I was asking Phil and Christian and Nash and whoever else, like, hey, is this arithmetic? Is this geometric? The reason I'm asking you is you don't want to just assume it's, arithmetic every time. Okay. So this is where y'all are going to work. And we're going to do a little Q&A. And you guys that are watching at home, I'm going to cut you off. And thank you so much.